everyone, this is Rohit Maurya, and this is the fourth lecture of Unit 4. As we already discussed that Unit 4 is all about column and struts and about the bending of beams, into which we have to find the slope and deflection. So we discussed three methods to find the slope and deflection in any loading beam. So next part is column and struts. So let's just get right. Here it is, column and struts. So what is column and struts? So if we discuss, we already heard many times if we talk about civil engineering, we see constructing columns. We heard many times what column is. It is a support system or a unit member of a structure which helps to get transfer different types of loading through beams. Basically, column is kind of a beam or which supports or handle vertical loading and transfer to the foundation. But what about the struts? What struts mean to, where it is used, how it is made, and why we are going to discuss it. So if we talk about the strut parts and why we are studying these two parts alongside. So the reason behind this topic to study in the first place, because column and struts shows one behavior commonly if it is used in any type of construction structure. So basically, columns can be made of any material. It can be made of concrete, made of wood, made of steel, composite beams, any type of. And either side, struts can also do the same. Struts are also made of any type of material, but the differentiation between these two is columns basically used or construct in a structure basically in purely vertical directional. Okay, columns are basically used in vertical way or vertical axis at any point of the structure to support load and transfer to the foundation. But in case of struts, what happen? Struts can be used either vertical, either diagonal, either in any kind of angle as the structure needs it. So can we give any example to the struts? Yes, we have an example for that. If we talk about the wooden structure or timber structure made of the wood, or we talk about the bridges, or we talk about the complex structures where diagonal beams are needed to transfer or transmit the diagonal loading or better stability of the structure. Okay, then struts are used. Okay, as we see many times in the wooden structure, we have a diagonal member along with the horizontal and vertical members, and these diagonal members work as a struts. Okay, and also in case of steel structure, we first thing or structure that come into mind is the bridges, where we have diagonal members. It can be in the one-sided or two-sided, which work as a cross-diagonal structure, which needed to transfer lateral loads or to give a lateral stability in the structure. Okay, let's just start. So what is the reason to study that topic? The reason behind to study column and strut here is, if these two parts of the structural member comes in different end condition or support condition, where they are fixed or where they are used. So how they behave and what are the maximum ultimate load that can make these two structural member fail. or the technical word is to pronounce this is, we say buckling load or crippling load. Buckling or crippling means at a load at which the member of column or strut, column either strut, is going to be fail in any specific end condition. End condition means there are 2 points of a beam or column or strut. There's 2 points. Then according to their type of the joint in both of the points, both of the ends, uh, decides whether what amount of load can be make that particular beam fail. Beam means column, either struts. So let's just start. Struts which fail by a building may be analyzed by Euler's theory based on the assumption. These are the assumptions that defines whether strut or column in a building can be formalized to find the failure point by Euler's theory. The assumptions are: first assumption is column is initially straight. Second is cross section is uniform throughout. The line of thrust coincide exactly with the axis of the column. The material is homogeneous, isotropic, as usual. The shortening of the column due to axial compression is negligible. What that means? The shortening of column due to axial compression is negligible. Why means this? In any of the case, however the load is extending or increasing by the structural load, we can't allow to assume in the analysis that the column going to be shortened. Means if the length of the column is L, then in no condition L is going to be shortened after loading or after under condition of loading. Okay, following cases is may be considered. So for solving different condition, we have a 4 condition. As I already told you that any kind of column and struts have 2 points, 2 ends. So according to their 2 ends condition, how or why, what type of their joint is, that decide what type of loading make it cripple or buckle. So first condition is both ends hinged, or we can say the pinned joint. Okay, one end fixed, other free. Okay, third condition, fixed at both ends, and fourth one is one end fixed, other free. So let's just start with the first condition, both end hinged. What they are saying is, consider a straight, initially straight, acted upon by axial load P through the centroid of the deflected shape of the straight is shown in the figure. That axis taken through the centroid of the end section, and the origin is assumed at a section at a distance x from O1. Let y be the deflection from the central line. Let's just see what they are saying. Here it is. So this is a figure. Okay, this figure here is showing that before bending the column is straight and load is applied here. Okay, which load is P, and after loading, what happens is, after loading, the shape of a column is deflected. How much I don't know, which can be any type. So if we cut a section at point here, which is y distance from the vertical axis and x distance from the horizontal axis apart, or we say according to the O point, the point we choose have a coordinate of xy from vertical axis. Okay, and load P is acting here, this point. So we cut the section here and find out the amount of moment generated through this P load. So we already have the equation, double differential equation, which is EI d2y upon dx2 is equal to mu, which is moment, bending moment, and we already find the bending moment for it. What is it? According to, if we try to find the moment according to this y point or xy coordinate point, we easily can get it. It is p into y distance. Either side you can choose it to find the moment. In both cases, p, the moment is py. Due to the condition we choosing, p load is rotating moment in the clockwise direction, or I say in the downward direction. That's why we choose moment in the negative condition. That's why moment is minus p pi, and the equation finally written as d2y upon dx2 plus alpha square y is equal to 0, where what we did is we divided the whole equation by EI, so the EI from this part cancel out and divided into this part, so we have the value of minus, and when it comes to this side it becomes plus, so what we have plus p upon EI into y, where p upon EI assumed as alpha square. What is the reason to assume as alpha square? Because this equation is a second degree partial differential equation, and by converting in this form is the reason to solve it, because we already have a solved equation whenever any second degree partial differential equation is written in this form. So we already have the solution for this kind of a equation, which is here. Thus the solution is here, which is y is equal to a sin alpha x plus b cos alpha is, where alpha is a arbitrary angle, or say it is not an arbitrary angle, it is alpha as it states here. Okay, x, which we already know, and a or b are constants. So to solve this particular condition, we need a boundary condition. We need a various boundary condition. So let's just get what are the boundary condition. If we try to figure out in this figure what are the boundary condition is, so we can easily say if x is equal to 0, if x is equal to 0, what is the value of y? Sure, the value of y is also be 0. Okay, that is the first condition. And if we say x is equal to what? L. If x is equal to L, then the value of y is also 0. Okay. Then in both the condition we have two boundary condition, and after applying one another, we can tend to a particular result, and that result will give us the particular relation that we going to be used to find the buckling or crippling load. Let's just see here. At x is equal to 0, y is equal to 0, and the value if the value we put in the equation above, we get b is equal to 0. In this equation, if we put x is equal to 0, then sin alpha x become 0, then a sin alpha x becomes 0, and y is already 0, then we got, and cos alpha x, we can easily say that b is going to be 0. Then in case x is equal to L, y is equal to also 0, then we have value a sin alpha L is equal to 0, because b is already been 0 in the first condition, so we already put in it. Okay, or the next thing we can say that due to by putting this, either a is equal to 0, okay, or sin alpha L is equal to 0. Both are the condition exist. But if constant a is 0, then this sin alpha L condition cannot be exist. So the solution cannot be happen. So we assume that a is equal to 0 cannot be the case. So we assume sin alpha L has to be 0. And we already know that what is the value of 0 in terms of sine, which is pi. So we put it sine pi, and the sine cancel out, and we give as alpha L is equal to pi. Okay, and we can find the value of alpha, which is pi upon L, and we put the value of alpha in this equation. Alpha is equal to p upon I. We put the value of alpha, which becomes pi square by L square, and then we can find the value of p easily, which we done here. P is equal to alpha square ei, and where we put the value of alpha, then become pi upon L square ei. Okay. In next lecture, we're going to find or reduce the other three conditions. How did we solve them? Okay. Thank you.